In this presentation, we are going to show you the uses of radiation in manufacturing and the production of goods by Timothy Draper and Daniel Marcantonio. In this presentation, it will cover the use of radiation in the bottling of beer, the production of sheets and metals, and the augmentation of plant traits to allow for a more efficient farming. Scintillator detectors are a precise measurement tool used in the manufacturing. This kind of measurement is a radioactive source, either Caesium-137 or Cobalt-60, sends out focused gamma rays. As shown in this diagram, a sensor mounted on the opposite side of the tank detects the radiation. This device is called the scintillator detector. It lights up when it is struck with ionizing radiation, and then the light flashes are counted, and from that data, the level of liquid in the bottle is determined. It may seem that radiation is dangerous, but the company that provides this technology welds the radioisotope to two pieces of stainless steel and shields it with lead so it does not contaminate the product. NaL, or sodium iodine doped with thallium, is the most widely used scintillator detector. Substances that aren't used in scintillator detectors have the property of absorbing radiation and ejecting the energy as photons. In this image, it is glowing blue because it is being bombarded by safe X-rays. Sodium iodide is a scintillator. However, more light is given off when there are thallium ions inside the sodium iodide crystal. In the diagram to the right, it explains this. Radiation gauges are used in the measurement of the thickness of steel plates. Americium-241 is used as the radioactive source. It has an activity between 37 and 185 gigabecquerels, depending on the need. It is a gamma emitter and emits the photons with an energy of 59.6 kilo-electron volts. Aluminium alloys can be measured from a thickness of 3 to 50 millimeters, iron alloys with a thickness of between 0.2 and 7.5 millimeters, and copper alloys with a thickness of between 0.1 and 4 millimeters. Mutation breeding is the use of radiation in agriculture. While the products aren't as far-fetched as Audrey 2 from A Little Shop of Horrors, they are certainly useful. Plant seeds are exposed to radiation in order to gain mutations that have desirable genetic traits. After the Second World War, both the United States and the Union of Soviet Socialist Republic decided to find a peaceful use for atomic energy. One of the ideas was to bombard plants with radiation and produce mutations. In this experiment, both countries thought that by causing genetic mutations, alpha and beta particles, along with free neutrons, can react with DNA, causing its shape, causing kinks and changes that can alter the genes. However, it can cause problems like genetic defects and cancer. In this short video, it will show the potential damage of what a DNA strand can go through during genetic mutation. Through the video, you will see strands being altered and twisted by the radioactive substance that comes in contact with them. Mutation breeding could make crops more salt tolerant, which would make them easier to farm in salty areas. Calrose 76 rice is a mutated version of Calrose rice. It is about 10 inches shorter than normal. This means that the less of rice crop would be destroyed in the strong winds, because the smaller the stem, the less gives it has when a force is applied. We must not forget that radiation can be dangerous. However, the ingenuity of scientists over the past century have used it to give us greater technology, better medicine, more precise measurements, and genetic augmentations. But we do not know what the future will bring. Thank you.